Alright, let's look at the homework 14.6, problem number 3. Alright, so let's find this directional derivative. Alright, so let's find the gradient first. The gradient of g is equal to, alright, so derivative arctangent is 1 over 1 plus x squared. And so in this case, we have rs, so it's going to be 1 plus rs squared. Then you have to take the partial derivative rs with respect to r, which is going to be s. Right? So that's the first component. And the second component is pretty much the same, except that since the partial derivative is done with respect to s, so it's going to be r. Alright? So if you evaluate this at point 3, 1. Alright, so I'm going to plug in. Alright, s is 1, so 1 over. Alright, so rs is 3 squared, so it's 1 plus 3 squared, so it's going to be 10. Alright, so r is 3, so it's a 3 over 10. Alright, so that's the gradient. Then we need to find the unit direction vector u. So this is going to be, alright, so v is at 5, 10. So we just have to divide by its length, actually. Yeah, that's the length here. Alright, so 5 squared is 25, and plus 100, 10 squared is 100. Alright, so you're going to get, let's see, 5, 10. And this is a square root of 125. Alright, so what's 125? 125 and divide by 5, so 2, 5, and 5, 5. Alright, so this is going to be, so these are 5 in common, so pull out 5, so it's going to be 1, 2. And then here, 125 is 5 square root of 5. So we can cancel 5 on top and a 5 on the bottom. So we end up with 1, 2 over square root of 5. Alright, so the directional derivative of g in the direction of u evaluated at 3, 1 would be, alright, so we have the gradient, alright, and then take the dot product with 1, 2 over square root of 5. Alright, so we're going to have, let's see, I'm going to just go ahead and multiply 10 and the square root of 5. And 1 times 1 is 1, plus 3 times 2 is 6. So this is just going to be 7 over 10 square root of 5. Alright, so let's type it in. Alright, so what we got was, oops, here, 7 over 10 square root of 3. Oh, actually, 5. Alright, so let's check the answer. Submit for testing. Alright, I came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.